remember S block, P block, D block, and F block. Remember that this doesn't have any element because this element is right over here. Okay, and S always start from 1, and then so you can label 1, 2, 3, 4, 5. P start from 2, so 2, 3, 4, 5, 6. D start from 3, and F start from 4. Okay, the answer to these are from the slide, so I'm not gonna go over this. I'm just gonna go over these answers, and I'll quickly go over PES and how to do PES. All right, oxygen. So you will notice this has, oxygen has 8 electrons. Sorry, complete one always start from 1s. So 1s, 2, 2s2, and 2p4. Okay, and you can count it, and that is as 8. Abbreviation. Short form, look for the noble gas, the one above oxygen. So you go one up and all the way down to the right, and you'll see that that is helium. Okay, so again, let me just quickly go over. Oxygen, go up all the way down, that's a helium. So with that, take care of all this. You don't need to write it. You start from this. So 2s and then go up, right? So that's what's going to happen. Okay. Okay, now let's go back. Okay, let me quickly do the next one. Mn, let's take a look. So Mn's right over here. If you want to do it from the beginning, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, and 3d5. Okay, so that's a long form. Now, how about short form? If you want a short form, go one up all the way down, AR, and then that's take care of all that thing above. So we start from here. So AR, 4s2, 3d, 5. Okay, let's go MN. 1s2, 2p6, 3s2, 3p6, 4s2, and then 3d5, or AR, 4s2, 3d5. Okay, let's do iodine. Okay, iodine here, right? If we're gonna go from the beginning, right? So we're gonna start reading from 1s again. So that would be 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, 4d10, 5p5. We're done, right? Now, if we don't want to do this because this takes forever, we can do shorthanded. One up, all the way down, KR. Let's take care of that whole row above. So we start from the new row, KR, 5s2, 4d10, 5p5. That's what we're gonna get. Okay, so let's do that. Okay, long one. 3s2, 3p6. Remember, after 4s is 3d. 4p, 5s. Okay, short one, KR. And then we get 5s2, 4d10, 5p5. Right, let's do silver and then fluorine. Okay, let's do silver. Okay, where's silver? Let's see. Silver, shorter than the iodine. Basically, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, 4d9. Okay, so that's what it's going to be. If we're gonna do shorthand, 1 up, which is the same thing, KR 5s2 49. Okay, fluorine. Let's look for fluorine. Right here, so really easy. 1s2, 2s2, 2p, 5. And shorter one, not so much, just helium, 2s2, 2p5. Okay, so let's do that really quick. Okay, now the next one is asking for only valence electron or valence shell electron. Those are easy. Look at the shorthand, right? Shorthand or condensed electron configuration. And then what you're going to do is you're going to pick up S and P, you copy it back. That's it. Okay, so when I rewrite it, that's it. Okay, now what if you have D? You ignore them. Just S and P. So that's 2. So this one's just, again, S and P. It's 2, 5P, 5. S and P, so 4s2, S and P, 2s2. Okay, now drawing. What are we going to draw? Orbital. S has only one orbital. Okay, that's 2s. And since there's 2 electrons, 1 up, 1 down, you're done. Okay, 4s2, same thing. 1 up, 1 down, you're done. Okay, this one, 5s, and then P has 3. So we need a 3 line. Okay, S, 2, 1 up, 1 down, done. Okay, P, 5. Up first. 1, 2, 3. Now you can draw down. 4, 5. Done. 5s2. Easy. Up, down. 2s. Up, down. 2p5. Up, 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 down, down. There's 5. Okay, let's draw about PES. Okay, I'm not gonna do the first question. I'm gonna talk about the picture first, and I'll come back to these. Okay, so for PES, what you need to know is you need to look at this bottom number. These are what we call as binding energy. The closer to the nucleus, the bigger this binding energy is. Okay, the closer to the nucleus, the bigger this binding energy is. Okay, so that's what we're gonna talk about. Okay. So that's how you're gonna look at them. If you're not sure of which shells it is, you look at the bottom one. A lot of times they just say energy. Sometimes you see this thing for U, which is potential energy. Yes, a lot of times they have unit, but sometimes they don't write unit, which is fine. All right. Also on the side, Y component, you'll see that it's a number electron or it's a related number electron. Again, a lot of the time they will give you number electron, but sometimes they don't tell you what number of electron is. So you just need to make sure that you are looking at them. Okay. Okay. Now, hold on. Give me one moment. Okay, hold on a second. Something. I have period table earlier and I closed it out, so I am getting back the periodic table. Oops, no, hold on, don't want to do that. Also, let's get back to this. Okay. All right. So, oops. So when you're looking at them, let's go back to PES. PES photoelectroscopy, right? So if you look at it, you're looking at related number of electron. Let's talk about PES. PES stands for photoelectrospectrum or electroscopy. We're not going to draw that yet because I want to first show you what is PES graph look like. So let's take a look at number 2 question, because number 2 question is really good because I have a few different ones here, right? So just comparing these two for now. So if you look at them, these two, they are very, very similar, but they're not the same, but they are very, very similar. First, you want to know is the bottom number, energy. Okay, this is still energy. It's just sometimes used in U, which is potential energy. Sometimes it's a binding energy, just energy. What you need to know is this. The closer the electron is to the nucleus, right? So it's the electron. This is your nucleus, which has neutron and then also proton. So the closer the electron is to the nucleus, the more attraction is to the nucleus. There is a larger, what we call as nuclear attraction, okay? This electron is kind of more freer. There's a weaker attraction there. Now, if you're up here, it's even more weaker, right? So that's what it is. So you want to look for the energy level. So you want to look for the highest. So here, this side is the highest, right? So this is normal. This side smaller is like 0, right? This is not 0, 0.1, close to 0, okay? To 1,000. So this is a higher one. Now this side is backward. You can see that this is 1,000 and this is 0.1. So notice that the in AP chemistry or in chemistry in general, this bar this bottom horizontal doesn't need to start from 0. So please take a look at it carefully. Okay. So what I want to tell is the peak that is closest to the biggest number, that peak is always 1s. Okay. You should know that peak is always 1s. Next you need to know is the right side, the y. Notice that this y tell you the number of electron. This one just say relative. So when they say relative, you need to know the scale in here. What kind of scaling they are giving you. So how do we tell them? The way we tell is very easy. You look for 1s. 1s need to be filled before you fill other. So therefore, this 1s scale has to be 2. Since there's 2 marks, each one is 1 mark. That's how we know, right? This one, they did tell us, so we'll get to them. Okay? All right. Let me go back to actually solve this question now that we kind of have a basic. All right, identify each element. So let's just talk about elements first. And then of course, this one's a label. So we're gonna do that anyway. So we already know this is a 1s. If you want, you can say 1s2, or you can just say 1s. Okay, so this is 1s. So after 1s, just in order, 2s, 2p, 3s, 3p. Okay, now how do you know how many? Remember I said this is 2 here. 1s2, this is 2 here. So that means this is 2, right? This little thing is 2. That means this is another 2. So this whole thing is 4. You see that? Okay. Anyway, so that's the side comparison. So we know that this has 4 electrons, which means 3p4. So you need to look at your periodic table to see which one has a 3p4. That would be sulfur. Okay, sulfur. Okay. Now, I said indicate the number of electrons that are contained within each sub-level. So that is gonna be show by, I'm gonna use a different color. Okay, these are really dim. I'm gonna use orange. Okay, that's 2. There's 2. There's 6 there. There's 2 there. And this is 4. Okay, that's how we know. Okay, again, let's see. We know that this one has 2 electrons, right? So 2s, 2p, 3s, 3p. Oh, this one's even smaller. 2, this is 6, right? How do we know? They tell you here. And then this is just 1. Okay, 3p1, this is aluminum. Okay, well, let's say Al, this is sulfur, so it's S. All right, DAE. DAE is, I didn't quite label it, I didn't quite write the question correctly. What I want to say was which electron or which peak correspond to the highest occupied energy level. That's what it's supposed to be. Okay, the question is really bad in here. So the question should ask you is the following. So let me just delete this question and this question, right? I should ask you is which peak contain electron in highest oh my god, where am I writing? Occupy energy level, or you can say energy sublevel. This one I really did bad questioning, sort of. Would probably say instead of that, I would probably use, again, like I said, instead of this, I would replace with this. Instead of this, I would say which electron or which peak is the lowest. And pretty much, I want you guys to tell me was this. This peak is lowest, right? Occupy energy level. How do we know? Largest energy. I would say binding energy, right? Show that electron in this peak is closest to nucleus. Compared to electron in other peak. Something like that along the way. So, and then when I went the highest one, same thing here, this one, right? This peak is a higher one. How do we know? Because it has the lowest binding energy, which means farthest away from the nucleus. That's why it's happening. Okay, let me just identify the graph and we'll look at the other one. So again, the higher one. So this is 1s, 2s, 2p, 3s, 3p. This is 3p1, believe it or not, because this is 2, right? So 3p1, what is it? Aluminum again, because this graph up here and this graph down here, they're the same graph. They're just flipped around, okay? You can kind of see that. So this is aluminum. Did I spell it wrong? Yeah, this is NUM. Okay. All right, let's take a look at more of these. Let's see if we can tell. highest, right? 1s, 2s, 2p. You can see that's a 2p1. So 2p1, who's going to be at 2p1? This is borrow. This one, 1s, 2s, 2p, 3s, 3p. Again, how do we know? This is 2, so that should be 3, 2p3. So since we know that it has 3 electrons, we're gonna say 3p3. That's a phosphorus. US. And then symbol is big P. That's a symbol. All right. So for the represent valence, these two are valence because SMP of the latest one. All right. Let's see. Valence right there. Valence. Okay. Let's try to sketch it out. Okay. We're going to start with this one first. Silicon. Okay. Before that, I'm going to quickly write the electron configuration of silicon. 1s2, 2s2, 2p6, 3s2, 3p2. Let's draw. Okay. I'm going to say this is like 1,000 or something, right? And then this is 0.1. So we're making it small. So I'm going to say this is 1s. Okay. That's like 2 level. Okay. I'm going to use different line to kind of mark this. Just because it has to be not as, it's not lying, it's just guiding so that I'm gonna draw 2 correctly. Oh God, can't draw a line here. Let me try my best. Okay, that's a line. Okay, that's a 4. And then that's gonna be my 6. All right, if you guys need it to. On the test, maybe when they're drawing, they have like line on the graphs, like the one that you see on the bottom. So it should not be a problem. Okay, 2s2, 2p6, 3s2, and then 3p2. Okay, something like that. Label, gladly. Okay, indicate the number of electron, 2, 2, 6. Actually, I'm gonna rewrite that 2p6 really quick. 2, 2. And then of course this bottom is energy. And then this top is number of electron. Which structure contains electron with the lowest ionization energy? Lowest ionization energy. Okay, so this is a term that I haven't teach you yet. Ionization energy is energy required to remove, that's an R, sorry, remove an electron, which means this peak here, okay? The reason is because furthest away, right? Electron furthest away from nucleus require release energy to remove. Okay, something like that. I'll give you more later. Okay, let's look at this. We're going to draw again. Neon and argon. Okay. Okay, I make a mistake here, right there. Did you see that? Argon symbol is not Ag. That's probably really confusing. It's actually Ar. So we're looking for neon and argon. Okay. Yeah, if you look at them, they are one on the top, one on the bottom. So neon, let me just use this side here to write it. Neon is 1s2, 2s2, 2p6. When you go to argon, it's 1s2, 2s2, 2p6, 3s2, and 3p6. So let's just draw neon first. On the test, you cannot use a different color to tell. So I'm just not going to use a different color to tell. I'm just going to say that this is neon, like really, really thick line. And then regular line, something like that. Okay. I'm going to draw the line for 2 and 6. 2, that looks like a 4. That's a 6. Okay. Binding energy, let's just go 1,000 and let's do 0 here. Okay, so this bottom is energy, not 0, like 0.1, like how we do that. Okay, careful with the debris mark. Number of electron, 2, 4, 6. All right, so let's draw neon. So 1s2, 2s2, and 2v6. That's the neon. Okay. Argon. 1s2, 2s2, 2p6, 3s2, and then 3v6. What you need to notice about this is you see that I draw 2s2p of the argon slightly toward the left or toward the bigger energy or binding energy than the 2s and 2p of the neon. Same thing with the 1s, right? The argon 1s is hold slightly tighter than 1s of the neon. The reason is because argon's nucleus has more proton. Therefore, if they're the same peak, argon electron will feel more nuclear attraction, right? So because they are all like 1s long. Now notice that 3s, 3p of that is less because it's further away than 1s or 2s or 2p. Okay, let's see. I think that's it. And then I'll see you guys in class later.